we are looking at changing the subject of a formula, and you might be thinking, why are we doing this? This is maths. Why are we doing it in science? But this is a topic that comes up really regularly in science, particularly in physics, but it does also come up in biology and chemistry. So this is going to be a really important skill that you're going to need to master to be able to do well in physics, chemistry and biology. So we'll start off. There are 9 questions on this sheet. This is the same sheet that is available and share my homework for you. I'm going to work through the first 3 together and then get you to do questions 4 and 9. So not 4 and 9, 4 through 9 by yourselves. And then we'll go on to the next page and we'll do question 1 and 2 together, and then you can do questions 3 to 6 by yourself. So we'll start with question 1. When it says to make y the subject of an equation, it means to get y by itself. So to have y on one side of the equation by itself, on one side of the equal sign, with everything else on the other side. So currently x is the subject of this formula. So it's x equals y times z, and you need to get it to say y equals something something. And so we need to get rid of z by itself. I'm going to write this out so it's a little bit bigger. So x equals yz. So we need to get rid of the z from this side and move it over here so it's with the x, and leaves the y completely by itself. And to get rid of something, you have to do the opposite of whatever is in the formula. So in this case, it's y times z. So the opposite of timesing is dividing. And so you will divide this side by z. And anything you do on one side of an equal sign, you have to do on the other side as well. Otherwise it stops equaling. So we divide that side by z as well. And when you have these two z's like this, so a times z and then divide by z, they cancel each other out, and there you have y by itself. So you can write it out left to right again, so it's y equals x divided by z. And there we have y, the subject of that equation. For this one, we have something slightly different. So we have b equals a, sorry, I wasn't quite in the middle, b equals a divided by c. And we need a to be by itself, so we need to get rid of the c from this one. So just like with this one, we need to get rid of c, and we said that divide is the opposite of times, so times is the opposite of divide. So to get rid of the c over here, we times it by c, and we have to do the same on both sides. And then we can cancel out those c's over there, and we end up with a equals b times c. We shouldn't really put the times symbol in there, should be just a equals b c, like that. Now the third one, slightly different. E equals d divided by f, and we want f here to be the subject. I'm sorry about that, that's my son's fire engine toy in the background, if you can hear that. So E equals D divided by F. And so we need to get F by itself. And we can't do this in one step with the other ones. Being on the bottom of the divide over here, at the bottom of the fraction, makes it really, really difficult. So we need to get it out from under. And we do that the same way that we dealt with this. The first step is to deal with it in the same way we did here, and times both sides by f. So I won't write the times symbol in there that time, it was bad of me. And then we cancel the f's out there. So that gives us d equals ef. So that first step, we're not quite there yet though, because we need f to be the subject, and so we have e times f, and if we need to get rid of f, we divide by f on both sides, and then we can cancel the f's out over there, and we end up with sorry, I've done the wrong thing there. I was getting e to be the subject. Sorry, go back a few steps. So we had D equal E. I've mucked it all up a bit, haven't I? There you go. Even I make mistakes. In fact, I make a lot of mistakes. We had D equals E F, and we want to get F by itself, and so we have E times F. We need to get rid of the E, so we divide both sides by E. We cancel those E's out, and we end up with F equals D divided by E. So we have F by itself, and that's the subject. So have a go at questions 4 to 9. You'll have to pause the video here so that you don't have me carrying on talking in the background. Pause the video, have a go at these. Once you've done them, restart the video again, and we will start on this sheet. Okay, so hopefully now you have paused the video and you've had a go at the other rearranging the formulae. And what we're going to do now is we're actually going to use that skill in a scientific context with some actual scientific formulae and some actual scientific numbers. So we're going to use 3 different formulae. We have one that we use in biology, because of course I'm going to include a biology one, which is one that we use for calculating sizes when we're doing using microscopes. So image size, or I, is equal to magnification, or M, times actual size, or A. So I could write that out again as I equals MA. The second 2 are both physics. So we have weight equals mass times gravitational field strength, or W equals mg. And the last one is speed equals distance divided by time, or S equals D divided by T. Now, there are steps that we want you to follow when you are doing questions like this in science, and it's the same for biology, chemistry and physics. Always do these the steps in this order. The reason why we ask you to do the steps in this order is because it maximizes the chances of you getting marks in an exam, even if you get the final answer wrong. So follow these steps in this order and make sure you show every step as well, because you don't want to be in a position where you have pressed the wrong button on your calculator at the last minute and you end up losing all your marks when really you deserve quite a few. So the first thing you need to do is read the question carefully. So you have calculate the magnification used to produce an image that is 1 centimeter long of an object that is actually 0.1 centimeters long. The first thing that you need to do is decide which of the equations that you know are going to be useful for that. So it wants us to calculate magnification, it tells us about an image, and it also tells us about the actual size of something. So in an exam, you'll have memorized all of these equations and you'll go through your mental library of equations, and you'll say, what equation do I have that includes magnification, an image size and an actual size? And you'll say, ah, I know, it's this one, and you'll write it down. In an exam, that's your first mark. The second thing that you're going to do is replace as many of those letters as you can with actual numbers. So I, image size. Does it tell you what the image size is? Yes, it does. It is 1. So you'll swap out the I for a 1. Magnification. Do I have a number for magnification? No, I don't. That's my unknown that I'm trying to calculate. And do I have a value for the actual size? Yes, I do. So I'll swap the A for 0.1. And that there is your second mark. Now your third mark is where you start to change the subject. So you need to get the M by itself. That means you need to get rid of the 0.1. So you'll divide both sides by 0.1. So over here those will cancel out and you end up with M equals 1 divided by 0.1. and then your last step is to do your working out. Now, no matter how straightforward a calculation might seem, there is no science paper that you will ever sit where you don't have a calculator. So use it. You do not want exam nerves to cause you to make a silly mistake and lose marks. So even though this might seem like quite a simple calculation, I use a calculator and it gives me my final answer is m equals 10. Now, sometimes there'll be one last mark available to get, which will be for units. For magnification, it's not really units we use, but it's just times. So we have magnified it 10 times. And that is our answer for that one. So we'll go through question 2 with you, and then you can have a go at questions 3, 4, 5, and 6 yourselves. So this one, it says calculate the time it takes for an object to travel 5 kilometers, that's a distance, at a speed of 60 kilometers per hour. So what equation do we know that links speed, distance, and time? It is this one, this one right here. And so we'll write that down. First mark, done. Second, find any numbers that we can substitute in. So S, do we have a value for speed? We do, it's 60. Equals D, do we have a value for D? We do, it's distance, it's 5. And T is our unknown, our value we're trying to work out. So this is one of the tricky ones, like in step 3 that I was talking about, where it is on the bottom of the equation, and therefore we need to do the 2-step changing the subject. So the first thing that we are going to do is times each side by T. So T times 60, and then we cancel out our T's on this side, and we end up with 5 equals T times 60, and we need to get T by itself, so we divide both sides by 60, and we end up with T equals 5 divided by 60. Now, it is worth noting that another reason why you do the numbers first is that it makes it obvious which one that you're trying to get by itself. So you don't end up doing what I did and going backwards and trying to get the wrong number by itself. It is clear that you want the T by itself, and so it's the 60 you're trying to get rid of on this side. Again, last step, work out your final answer, use a calculator. It gives me a horrible number. I'm going to round it to 2 significant figures. Hopefully you are all confident with that after yesterday, to 0.083. And my units, so it's time, so my units are going to be something like minutes and seconds or hours. So I look back up at my question and I see that my speed was in kilometers per hour. So I'm going to use the same time unit that I used there for my answer. It might be that a more complicated version of this would ask you to give your answer in minutes or seconds, and then you'd have to convert this into seconds. But unless it specifies, you can use whatever unit is appropriate. Now, I'd like you to have a go at questions 3, 4, 5, and 6, and then take a picture of your answers to these ones and your answers to these ones, upload them onto Show My Homework, and then go and learn something else or have fun if this is your last lesson of the day. Bye.